Hi class, today we're going over the test review, the practice test that is on your page 16 of your packet. On the first page of the practice test, on page 16, we have a few definitions that you need to know for your test. This is to evaluate, simplify, and solve, the order of operations, giving an example of the distributive property, and the properties of equality. All of these are uploaded to your Google Classroom, and you can also find them in your packages and your notes. So now let's move on to page 17. And here the first problem says match each property to the example that models the property. This is similar to the example on page 3 that we did in that first week of school. So let's read the first property, multiplicative property of 0. Multiplicative tells me I'm dealing with multiplication. Property of 0 tells me that I'm multiplying by 0. So if I take the number 3 times 0 gives me 0. Now I have to look where do I have a similar example on the right side. And I notice that F is very similar to that. We have 8 times 0 gives me 0, and that is the multiplicative property of 0. The next one is the additive identity. Additive means the operation we're looking for is addition. Identity means we start with a number and end up with the same identical number. So what would we have to add to 3 to have equal 3? That is 0. 3 plus 0 gives me the identical number we started with, which is 3. Looking on the right side, what example would fit that scenario? And we see that C is very similar. It says x plus 0 equals x. We do have addition, so it is additive. Identity because we start with x and end up with the identical value. So here we have C. The next one is the multiplicative identity. The word multiplicative again tells us we're looking for multiplication. Identity tells me I'm starting with a value and ending up with the same identical value. So what would I have to multiply 3 by to get 3? That is 1. Let's look on the right side at the examples and see what looks like that. And we notice A says 12 times 1 equals 12. We start with 12. We multiply by 1 and we end up with the identical number. So this will be A. Next property, additive inverse. Again, additive tells us we're looking for addition. Inverse. What is the inverse of a number in addition? So the inverse of 3 would be -3. So we're basically canceling out our starting value, which is 3. 3 plus -3 gives me 0. If I look on the examples on the right side, I see there is one scenario that fits this, and that is B. Here I started with -6, and I added its opposite, which is +6. And the 2 canceled out to give me 0. So the additive inverse is represented by B. Whenever you go through a problem like this, which you will have on the test, make sure you understand the words. For example, the next one, multiplicative inverse. Multiplicative, you're looking for multiplication. And you can always write a small example like I do and then look at your actual examples to see what is similar. So multiplicative inverse, I'm looking for multiplication. And for example, if I start with 3, what is the inverse of 3? in multiplication. The inverse of 3, remember, that is the reciprocal. If I write 3 as a fraction, I write it as 3 over 1. The reciprocal of 3 over 1 is 1 over 3. When I multiply the 2, my 3 cancels out and I get 1. So the multiplicative inverse is represented on the right side best by J. See here, I start with 1 over 7 and I multiply by its reciprocal, which is 7 over 1 or just 7. When I multiply the 2, the 7 cancels out and I get 1. That is the multiplicative inverse. Next one, the commutative addition. Commutative addition, again, we're looking for what sign or what operation. We're looking for addition. So I'm going to put a plus there. Commutative, remember the word commute means to move places. So for example, if I have 3 plus 4 equals, in the commutative property, they would change places. So 3 plus 4 is the same as 4 plus 3. The commutative addition tells me that if I change the place of the numbers being added, I still get the same quantity. Looking on the right side of our table, I noticed that there is one example that looks similar to this, which is I, but here you have another element of multiplication. We have 2 times x plus 5 equals 2 times 5 plus x. Don't let the multiplication by 2 distract you. We are looking specifically for addition and for the commutative property. So regardless what other operations we have around the addition commutative property, we are only specifically looking for that property that is mentioned. So we are only looking at the x plus 5 portion of this problem. So as we see, we do have addition, and the x plus 5 changes into 5 plus x. So the x and the 5 commuted or changed places. So this fits the bill for the commutative addition property. This will be I. Next one, we have the commutative multiplication. Here we're dealing with multiplication, so I'm going to put the multiplication sign or operation. Commutative, similarly to the addition commutative property, if I have 3 times 4 equals, if I change the places of 3 and 4, and now I get 4 times 3, we still get the same result. 3 times 4 is the same as 4 times 3. If I look at my examples, I see D looks similar. In D, I have multiplication, and has anything commuted? Has anything changed places in D? And we see that x and y changed places. Remember, we don't have to see all of the numbers or values change place. It's enough that x and y change place. On the left, we have x times y. On the right, we have y times x. So this is the commutative multiplication property. This is D. Next one, we have the associative addition. The associative addition, the word addition means that we have the plus sign or the operation of addition. Associative means that the values themselves do not change place, but what does change is the parentheses. Remember, parentheses is a grouping symbol which represents associative. So remember, parentheses is a grouping symbol. To associate means to group yourself with others. For example, if I have 3 plus 4 plus 5, let me erase this so you can see better. If I have 3 plus 4 plus 5, and I first group 3 and 4 together, so I associate 3 and 4, This equals the same as if I associate or group together 4 and 5. So you noticed in this example, the numbers themselves did not change places. 3 plus 4 plus 5 equals 3 plus 4 plus 5. The only thing that did change is the parentheses. The first time we have parentheses around 3 plus 4. 3 plus 4 associate together. And then we have parentheses around 4 plus 5. So this time 4 and 5 are associates. So remember, don't confuse the associative property with the commutative property. In the commutative property, the values actually physically change places. In the associative property, the numbers or values do not change place, only the parentheses change. Looking on the right side, we see example G fits this bill. We have 2 plus 3 plus 1 equals 2 plus 3 plus 1. None of the numbers actually changed place. None of the numbers commuted. The only thing that changed was the parentheses. So this is G. The next one, we have the associative multiplication. The word multiplication means we're looking for the operation of multiplication. Associative, similarly to addition, we have numbers that do not change places and only parentheses change place. So 3 times 4 in parentheses times 5 is the same as 3 times 4 times 5. Looking on the right side, we see example E. So let's look at E. X times 3 times 9 equals x times 3 times 9. None of the numbers physically changed places. All of the values are still in the same place, so they did not commute. The only thing that did change was the grouping or the parentheses. So this is the associative multiplication. And the last one, of course, the one left over is H, the distributive property. To distribute means to share. So if we think about sharing, in our example, we share that number 4 inside of the parentheses. Since 4 is multiplied by our parentheses, we multiply the 4 by each number or value inside the parentheses. So 4 times x gives me 4x plus 4 times 3 gives me 12. Moving on now to the next problem, evaluate the following expressions. Remember to always show work in any test, quiz, classwork, project, or homework. You always have to show your work. If you just put the end result, that will not give you points. So let's look at A. We are given 8b squared minus a, and we have to evaluate. Remember, to evaluate means to replace your variables with any given values and then calculate your expression. So I will rewrite my expression, leaving blank parentheses wherever I have a variable. Next, I will replace my variables in the blank parentheses. So the first variable is b. So I replace that parentheses with a 2. The next variable is a, and I will replace that with 4. Order of operations, first thing I need to do is calculate parentheses. Since my parentheses are done, there's nothing there to do. I move on to exponents. As you see here, I have one exponent, which is 2 squared, and I'll write it here on the side. 2 squared equals 2 times 2, which is 4. Remember, when you calculate an exponent, especially if I'm dealing right now with squared, we are multiplying the base twice by itself. So 5 squared would be 5 times 5, which is 25. 6 squared is 6 times 6, which is 36, and so on and so forth. So in our example, I still have that 8 times 2 squared gives me 4 minus 4. Order of operations, I do multiplication before I do subtraction. 8 times 4 gives me 32, minus 4, which gives me 28. And that is my final answer. Let's look at B. Again, I will rewrite my expression, leaving blank parentheses wherever I have a variable. I am replacing my variable with -3. Remember, between -3 and -5, we have multiplication. So what is -5 times -3? It is positive 15. A negative times a negative is a positive. 15 plus 2 gives me 17, and I am done. Moving on to page 18, it says at the top, simplify the following expressions. Remember, to simplify means to get rid of any parentheses and combine like terms. Whenever you solve an equation, you must do those two steps first before anything else. So whenever you have an equation, make sure you have no parentheses left and you have completely simplified, meaning you have added or combined all of your liked terms. In our first example A, we have two like terms, 5x and x. So we can go ahead and combine them. 5x plus x gives me 6x, and I still have that plus 2. Here I am done because these are no longer like terms. One has an x in it, and the other term does not, it's just a constant, so we cannot add them. Looking at B, we have to distribute the 3 inside of the parentheses in order to get rid of the parentheses. So I'm going to do 3 times 5x minus 3 times 4. So when I'm distributing the 3, I'm multiplying by each term of the parentheses. Equals 3 times 5x gives me 15x minus 12. Here I am done because I can no longer combine 15x with 12 since they are not like terms. Looking at C, to simplify again means to eliminate parentheses and combine like terms. Combine like terms. In example C, I have parentheses, so the first thing I need to do is eliminate those. So I'll get -6 plus 2 times 3x squared plus 2 times 2 plus 3x equals -6 plus 2 times 3x squared gives me 6x squared. Here, pay attention, only your x is squared. You're not squaring your 3 and you're not squaring your 2. Plus 4 plus 3x. And the last step, we can combine any like terms. So I have -6 and 4. They are both constants and you can combine those. -6 plus 4 gives me -2. Here I have a 6x squared and a 3x. Since one has an x squared in it and the other term has only an x, I cannot combine these two. So pay attention, when you don't have like terms, you cannot combine them. So I will leave them the way they are, 6x squared plus 3x. And you are done. The most correct way to rewrite this expression though would be 6x squared plus 3x minus 2. The correct way would be to always start with the highest value, the highest exponent of your variable, which is x squared. Continue down to the lowest exponent, and then you should leave your constants last. Let's look at D. Here I have parentheses that I need to get rid of. So what I can do is put a 1 in front of the parentheses. 1 multiplied by any quantity is just that quantity. So that 1 does not change anything. But now I can distribute on the inside of the parentheses and get rid of the parentheses. As you see, here really nothing changes. All I have done is eliminate the parentheses. What can I combine? Look at your 5x and look for another term with x in it. So that is negative 2x. 5x minus 2x gives me 3x. Then I have a 10x squared, which cannot be combined with anything. And finally, I have my constants, 3 and negative 7. 3 minus 7 gives me negative 4 or minus 4. Here I am done. If I want to rewrite it, I can write it as 10x squared plus 3x minus 4. Let's look at example E. Here I have a 4x to start with. Can I combine that 4x with anything else? As I noticed, I have a negative 2x, so I can combine those two terms together. 4x minus 2x gives me 2x. Next, I have this 3, which is a constant, and I have this negative 1, which is also a constant. So 3 minus 1 can be combined, and I get plus 2. Next one, I see a positive x squared and a positive 5x squared. Since both terms have x squared in them, I can combine them to get plus 6x squared. At this point, I am done because I no longer have any like terms to combine. If I want, I can rewrite this expression as 6x squared plus 2x plus 2. And the last one here is f. Remember, first thing I do is eliminate parentheses if I have any. Here I can again multiply by 1 in front of my parentheses. If I distribute that 1, nothing changes because it's just a positive 1. If it was a negative 1, that would have changed the signs inside the parentheses. So I get 2x minus 3y plus 3 plus 2x plus 5y minus 7. So nothing really changed. Next step, combine like terms. So I have 2x and I look for another term with x in it and I see I have another 2x. 2x plus 2x gives me 4x. Next term, I have negative 3y. And I'm looking for another term with y in it. And I find 5y. Negative 3y plus 5y gives me positive or plus 2y. And finally, I'm looking at my constants. I have a positive 3 and a negative 7. I can combine those two. 3 minus 7 gives me minus 4. And now I am done. Looking at the last problem here in the test, we have problem 8. It says solve the following equations and show your work. So here I'll just rewrite it. X minus 5 equals 42. This is a one-step equation. My goal is to get x by itself, so I need to get rid of this 5. Since I have subtraction here, I will do the opposite of subtraction or the inverse of subtraction, which is addition. And I'm adding a 5 on both sides of the equation. My 5 goes away and I get x equals 42 plus 5 gives me 47. This is answer A. Next one, I have negative 5 plus 2x equals negative 11. This is a two-step equation. And the first thing I need to do here is isolate the term with a variable in it. My variable term is 2x. That means I need to get rid of this 5. The opposite of subtraction is addition. And I do that on both sides of the equal sign. Negative 5 plus 5 gives me 0, so that cancels out. And I have 2x equals, what is negative 11 plus 5? This is negative 6. Next thing I need to do is isolate my variable. So first you isolate your term with the variable, and then you isolate your variable. Between 2 and x, I have multiplication, so the opposite of multiplication is division. So on both sides of the equal sign, I divide by 2. My 2 cancels out, and I have x equals negative 3. And that is answer B. For the next one, I have 6x minus 2 times 3 plus 2x equals 26. Here, the first thing I need to do is get rid of parentheses. In order to get rid of the parentheses, I need to distribute the negative 2. So I get 6x minus 2 times 3 gives me 6, minus, because negative times positive gives me negative. So minus, and 2 times 2x gives me 4x. Equals 26. Now that I've gotten rid of the parentheses, I can combine like terms. So I notice I have a 6x and a negative 4x. I can combine those. 6x minus 4x gives me 2x. I still have that minus 6. Equals 26. Next step, I need to isolate the term with the variable in it. That term is 2x. In order to isolate it, I need to get rid of this 6. Since I have subtraction here, I'll do the inverse of subtraction, which is addition. So I am adding a 6 on both sides of the equal sign. My 6 cancels out, and I get 2x equals 26 plus 6 gives me 32. Next, I need to isolate x. Between 2 and x, I have multiplication. The inverse of multiplication is division, so I'm dividing by 2 on both sides. My 2 goes away on the left, and I get x equals 16. So answer A. And the last problem in the test is negative 4 plus 3x plus 2 equals 3 times x minus 4 plus 10. First thing I need to do to simplify is to get rid of parentheses. To get rid of the parentheses, I need to distribute the 3. So let's write negative 4 plus 3x plus 2 equals 3 times x gives me 3x minus 3 times 4 gives me 12, and I still have that plus 10. After I've gotten rid of parentheses, next thing I need to do is combine like terms. Looking on the left side of your equal sign, I notice I have 2 constants I can combine. Negative 4 plus 2, which gives me negative 2. I still have that plus 3x equals. Now looking on the right side of your equal sign, I have 3x, and I notice the 2 constants I can combine. Negative 12 plus 10 gives me minus 2. Now that I'm done with combining like terms, I notice this is a case where I have an equation with variables on both sides of the equal sign. Remember, when you have variables on both sides of the equal sign, you must move one of them to the other side. You need all of your variables on the same side of the equal sign. It doesn't matter which one you move, so let's move the one to the right. I'm subtracting a negative 3 in order to get rid of that 3x. So I'm subtracting a negative 3x. So plus 3x minus 3x cancels out on the left and gives me 0. and I have that negative 2 still there, equals 3x minus 3x on the right side also cancels out to give me 0, and I have that negative 2 still left. So now I ended up with something that looks like this. Negative 2 equals negative 2. This situation is always true. We say this is always true. Negative 2 is always equaling to negative 2. If you remember from previous lesson, it's also in your packet, we said when we have a quantity equaling to the same exact quantity in an equation, we have infinite solutions. Infinite solutions. So when you get to something that is always true, that means we have infinite solutions. This was it for our practice test. Thank you for watching, and hopefully you get to work on this practice test before the real test. Make sure you look over page 16 and remember your definitions. Thank you. Have a nice day.